Hi Martin,
Hi,
how you doing?
pretty good. What about you?
Yeah, no, I'm fine, thank you. Yeah, I saw the discussion about lookup again in the chat.
Yeah, it's an ongoing discussion. Um, I think we're good. We're getting somewhere. It's a complex issue.
Yeah, I mean, it's the key thing to get right, isn't it? Like it kind of holds everything together. The whole composite spec is held together with this, so it's important to
Yeah,
get right.
yeah, they're really foundational concepts that we need to get right.
Hello, folks.
Hello.
Hi Pascal, hi.
I need to look the recording to see what you have already discussed. How are you doing, guys? Hi, Derek. Hi, Michael.
Hi guys. Sorry, I had a board meeting, but cut it close. 1 second. Let me just get up to speed on the agenda, and then we can start. Awesome. Okay, let's start. Let me remind you that by being here, we all agree to the GraphQL spec membership agreement and to the GraphQL code of conduct. With that, let's do a quick round of introductions in the order of the agenda. Has everyone already arrived and added themselves to the agenda? Let me quickly check.
Sergey is still missing.
Sergey is missing. Doesn't
Is
matter. Let's
Camille
just...
attending?
No.
Camille's name's not there at least.
No, he's here.
Oh, but he's here. He's
Ah,
here.
I, okay, let's do a quick round of introduction until his turn is his audio will have connected. So my name is Michael. I'm the host today.
I am Pascal.
Hey, it's Derek from Paul.
Martin from Apollo.
David from Undergraph.
Okay,
Hello,
Sergey.
everyone. I'm coming from the guild. Just joined.
Yeah, and I'm awaiting your pull request.
Yeah, you
Just
merged
to have
one like 2 hours,
just
the one that I created like a week ago. So yeah.
Amazing. So we have at the moment one topic, and that is the continuation of the Lobka key entity discussion. And there was also input from outside. I talked to people, so there is a lot of traction around that. And maybe even Stephen joins later, and then he has also some thoughts on that. Okay. Let's start on this. Pascal has posted, I think in the morning, a document. So I'll leave the word to Pascal.
Yeah, can you guys see my screen?
Yeah.
So I've also linked this in. Now you have to be careful that we connected the threads correctly. So you posted a gist. There was documentation on your gist, and I appended this also as a link to your thread.
Yeah.
There was also outside collaboration from someone which isn't in the workgroup meetings on your thread about the entry exit points where a key needs to be defined, and that essentially when there is a lookup, there could be there could be a way to resolve it. And based on this, I had some thoughts, and I just want to talk this through because there's a few questions at the end that we should all agree on. And it also involves a bit of Shane's. So if Shane wants to look back on Shane's question, what actually is an entity and how are entities defined? So essentially, but I will just go quickly through it. You can read it up in detail later. But essentially, what this says is that there is we need to define what we should include in the core specification, because what is in the core specification becomes essentially mandatory for all implementations to be compliant with. So whatever we put in the core, when you want to be composite schema compatible, then you have to implement everything which is in the specification. Now, I looked at it a bit from the execution point of view. That's what we discussed last time, that theoretically this is enough to have an executable schema. This information that there's a product which is lookupable, let's call it this way, by the SKU. And if you have this, then you can look it up by product SKU and you can resolve the product details. This is how this would be 2 requests. First request goes to schema A, second request goes to schema B. Now, what we can do as an addition on top of this is we can add explicitly double bookkeeping. That is that every subgraph must declare how an entity is referenced, then each lookup must define the key, for example, like this. So that you essentially say that there is a key field, SKU, and this key field basically matches the lookup that you have here. So you have a key and you have a matching lookup. In this scenario, additionally to the minimal executional thing, we need to define, there's a mistake here, we need to define a key on schema B. We also need to define, we need to add SKU to schema B, right here, because in the first iteration, we do not really require it to be on the product. But as we define a key, this key should point to something, so there must be a field SKU on this subgraph as well. And then we need to mark, that's the mistake, this shouldn't be here. We need to mark this SKU field as shareable on the other subgraph to make it shareable, so that we can actually define it in 2 places. Here, it's implicitly shareable through key, and here it's shareable because we have mentioned it to shareable and because this shouldn't be here. Now, there is also the entry exit point discussion that we had last week, where we can even restrict this further down a bit. And we can say that when we make it more explicit, we can say that a key is actually the exit point. So to go from this subgraph to this subgraph, what we have to do is we have to define a key here as the exit point and the key here as the entry point. So that's an additional layer that comes on top. This has a bit of the side effect that if a developer forgets, let's say in schema C, the key directive, then we may have a performance issue because we have to do an additional hop to satisfy all of the key fields. And then we can take this even one step further. It goes a bit into what David said last week, that shareable actually is completely implicit. So it's enough for one graph to add a shareable directive to make it shareable in all of the domain. And we could even say that shareable actually needs to mention from where it is shareable from. So let's say that this field should be shareable. Then we need to say that it's shareable to here or from here to here. We haven't really talked about this in detail, but that's a concept that came up. Now, this approach that adds obviously more complexity and so on and so forth. So this is basically from the minimal executable composite schema to the most complex version of what we have discussed. It's a bit of everything mixed together in one document. Now, what we have to decide is what should be in the core specification and what should not be in the core specification. So we have to say, we have to find a balance between complexity and adoption, because it could be that if we make this too complicated, that the adoption will be hindered, right? Because every server that wants to be compliant with the composite schema then has to implement all of the features that we have defined. The second thing that we have to define is what is an entity and what's the role of lookup. Because if lookup already is enough, so if we say that lookup always returns an entity, if this is the rule, then essentially a lookup would be enough to define an entity. And then we can question if we need to have a one-to-one mapping to key or not. Or is there a scenario where we need both? That's the other thing. Then One thing which I mentioned briefly at the last schema composite schema work group is that theoretically we can also, a lot of these features are schema governance. So like this could be very helpful for big organizations which have teams which work in different time zones and are otherwise not related to each other. But it might not be helpful for the team which actually drinks coffee every day in the same office, because they can just ask, hey, Michael, is SKU stable? And they say, yes, it is. And if Michael breaks my schema, I can walk over and hit him on the head and tell him that he broke my schema. So
it's also not clear that this is best solved through a directive. You might have explicit workflows that help you deal with cases like this.
yeah, it's
Yeah.
we haven't discussed this in detail, right? But it's a bit of what's the governance rule that you want to enforce? Because theoretically, if we start from here, everything else could also be looked at as a governance rule. Like
and I think that's the part I disagree with. Because I definitely agree that some things are best left out of the core spec, and like more complex governance doesn't belong in there. But keys to me are a core part of the federation model, entities and keys. And it's not just a governance feature.
yeah,
It's actually it's about modeling. It's about modeling your schema. It's about to me, it's actually about simplifying the model, because if you look at a minimal executable composite schema like this, a lot of the behavior is implicit. And as your schema grows, it becomes more and more difficult to reason through the expected behavior. You have to go look for the lookup fields to know which types are considered entities, which fields are considered key fields. And to me, therefore, the key directive is not adding complexity, but it's actually simplifying the mental model for users. It's allowing them to think in terms of entities and keys, which I think is a natural way of thinking about these types of schemas.
I think the question that we have to answer is a bit what like if we talk about entities, what
Yeah.
defines an entity? Because in if we talk about Apollo Federation, an entity is defined with a key.
Yeah.
That's how an entity is defined in Apollo Federation. If it doesn't have a key, then it's not an entity. Now, the question that comes up a bit is this enough to define an entity and this enough to define the key? Because if you look at how you would discover what's possible is you just look at the query type and then you would see what's up. So it's not like here, you essentially have to look at product and at the query type to know what is possible. Well, Federation doesn't have this, right? In Federation, it's enough to just look at the product type to know that this is resolvable through the entity. But if we add key, there's actually two places where you have to have a look. So you have to have a look at the query type to see the lookups, which is essentially how this can be fetched. But you also have to look about the keys.
Because well, you don't necessarily have to look at both. Like if our requirements guarantee that lookups and defined keys in a subgraph are always in sync, it's enough to look at product to know that it's resolvable by SKU.
Derek is next.
I agree that technically you could derive a lot of stuff to the lookups, but a lot of stuff is much easier and much simpler mental model if you have these explicit keys. Because when you're thinking about the objects that, oh, this is an object that's uniquely identifiable, right? If I'm looking at this object, is what is my unique identifier on it? And that's what the key is, right? So it's kind of like the database primary keys or unique keys. But the question, well, the one issue, potential issue, is that we allow currently this implicit keys to the shareable stuff, right? So if the field is shareable on a type, it can actually be a key in another place, and I can use that as to jump to another one, which I think that part is, to me, somewhat confusing because it's not immediately it doesn't immediately jump out that this is actually how you can join on that. So what I personally would think that could be a potential solution is that we should require explicit keys to identify the stuff, but if there's a way to jump to another subgraph to another implicit key, like without the S, so like the other example had the key on ID in one graph, and skew is shareable, so you can jump to another one as true skew, to make it maybe a composition warning that you have the missing some keys, right? So maybe so do not fail it, still allow it, but make it as a warning that the end state that folks should have those explicit keys inside of the stuff.
Yeah, and we could even specify that it's undefined behavior, it's implementation specific if you don't have that key, because we want to support sort of the current behavior that we offer, but not necessarily restrict people from implementing things differently, I think.
Yes, we can definitely specify that. David?
Just preface what I'm about to say with, if I, being new here, like if I have gotten anything completely mixed up or anything, like please just stop me and say, it doesn't work like that. But if we look at so kind of follow what Derek said about how it's implicit and having the handshake to make things explicit. If we flip it on its head, because my opinion is this is the right way, but if we flip it on its head, and you actually just for a minute considered that keys don't exist at all as an argument for not having the implicit key, because essentially everything is already encoded inside the lookup itself, right? Like everything that's needed for the lookup to function is encoded inside the lookup, as long as you define the key on that object inside that graph. So the key is essentially just a piece of information to make things explicit already, even for the lookup. So what is the argument to not have keys everywhere? It's like, for me, it's either you have keys nowhere or you have keys everywhere. It doesn't make sense to me that you have keys sometimes and you don't have keys other times. Like it's one of the two for me, in my opinion.
How do you mean we have them sometimes?
So for example, here you have in the graph where the mouse is now, it's saying that you can have a lookup where it can be identified by SKU, right? From another graph. It's coming in from another graph with SKU. And of course, in this graph, the product doesn't define SKU, because I assume this is because this graph is not responsible for that field. It can identify itself from SKU, but it is not able to actually resolve SKU itself, right?
Yep.
Yeah, which is like the minimum. If you think about resolver function, it doesn't mean that you necessarily can represent it.
Yeah. So I guess I mean, for me, I don't know. Now I'm kind of going against my own thing, what I've just said, to be honest, after having kind of rubber ducked this. I'm not sure, like I just feel it should either be explicit at all times or essentially not there at all. But now I understand that I actually what the difference is here is that, obviously you can receive something but not be able to have responsibility for it yourself, sort of thing. So maybe I've
And
got
that is a pattern that you have in distributed systems a lot, right?
Let's fix this quickly. It's
Yeah, but I actually agree that having a key in all cases makes the most sense here, to be explicit in all cases. And there can still be a difference between keys that support lookup and keys that don't. Like you don't necessarily need to allow lookup by a key in order to expose a key. And to me, the main argument for requiring key is, I would say, developer experience. I think it allows us, I mean, it's the mental model, but also if every error is a satisfiability error, basically, satisfiability is pretty hard to reason about for users. And keys offer some guardrails here. They allow us to give you much more specific, actionable feedback. Like you're missing a key here, or there's no corresponding key between these subgraphs. So I think it's also worth exploring from that side what keys give us.
Yeah, so just to understand you two right, we're not talking about this one where we double bookkeep the key on one subgraph. We're actually talking about, maybe David, you're talking about the key should be on both subgraphs.
Yeah.
So you know from here, this is the entry point, exit point discussion that we had, right? So you
Yeah.
can only go from here to here if you can only go from here to here if it's defined as a key here, otherwise it will not work.
Yeah, and that's sort of what we might call the strict mode. It's like Apollo Federation is more flexible right now, and this we would likely sort of still support the old behavior and generate a warning. But I think the situation we want to get people to is to be explicit in all cases where that's possible.
So one thing I have two comments quickly on this. So one thing is that if we now look at this schema and if we double bookkeeping on both subgraphs, right? We have the entry exit points thing.
Yeah, I think product also needs to be a lookup here, right?
Well, it doesn't have to, because it could be that this doesn't need to be looked up. This could just be the query route.
No, but that still makes it a lookup. Like lookups are used for clients.
Yeah, but this we have to distinguish. There might be, like in this spec we describe just the lookup behavior that we need for the spec, right? There could be broader use for lookup that we have to separate out into a separate subspec then. But like from the spec standpoint, you could just define it with this is just an entry point. I don't want to use it as lookup. And then you can only go to run graph. I mean, it's you might want to use it as lookup. I agree, but like this is technically a valid schema, right?
Let's
because there's no way from the other schema back. It's just you can flow.
Let's change this instead of product ID. Let's change this to just best product without any parameter. The best product that you can get.
Yeah.
And then you have the best product returns product, which is the entry point. And now one thing to note is that when you look at this graph, when this is best product, you always, and this is the critical thing here, you will always have to look at the query type in all cases to know how the execution behavior will be. Because the thing is that if I look at product, I see that this is unique. This is uniquely identifiable. So I have the SKU here. But I have no idea with this information that there is no lookup corresponding to this key. So if I just look at this, I expect that name and price can be resolved as soon as I have an SKU. But that's not true. Name and price can only be resolved on the root, on best product. Because even if there is an SKU here, a key here with SKU, it doesn't imply that this is also a lookupable field. And that's where
by itself, it's just an exit point, not yet an entry point that requires the lookup.
Yeah, but if you want to reason about how the subgraphs or how satisfiability works, you actually always have to look at the query types in any case, because the query types are the ones which define how you do the transition, or however it's called, the transition, the move, or however you want to call it, from one subgraph to another subgraph. The exit and entry points, it's fine, it's a terminology thing, but it's always the query type which defines which moves are possible. If we really do the double bookkeeping, because that means that if we have the exit point here and the entry point here, it could be that we just need this for an exit point, but we can only know that name and price is not lookupable if we look at the query type. Just one.
I mean, that's typical GraphQL, right? You always have to look at the root types to know what entries are possible. But David has his hand up.
Yeah. So I've kind of consolidated what I was trying to say before. So currently, I guess the function of key right now, in the spec itself right now, if you were to remove the whole concept of key altogether, everything was encoded in the lookup, etc. Am I correct in thinking that key, like at key as it stands now, is just to create explicit kind of bookkeeping to support lookup? Does that sound reasonable?
Yes, it's at the moment it's just an indication. Like it could be useful for other things like caching and stuff. You could describe, okay, we don't have a lookup to this key, but this is a key that identifies this entity. And then the gateway could do caching with it or whatever, right? On top of the lookup logic. But that is not a concern of the core specification. It just would identify that these properties are unique. Whereas the lookup describes that you can uniquely identify this entity that we return you with this key, the arguments that you pass into this lookup. So you have a stable key, which are the arguments, and out you get an entity.
Thank you. So just again, coming from a very naive and newcomer position, for me, it makes sense that either this explicit bookkeeping is at all times, or you don't bother having it in the core spec at all, because essentially if you look at just the query types and at the lookups, it's not as easy to see with not having the keys there as well, but you can see how things interact and work with each other without the keys being explicit in the schemas. You can't remove the lookups. The lookups are doing everything essentially, but you could remove the keys. And my point here is you either remove all keys or you make all keys explicit. And I think those are the two parts of the paradigm for me that that should be picked. But again, just my naive opinion.
I mean, I generally agree with one thing, but I have to disagree with the other thing, because adding keys on both subgraphs makes it harder to understand what's going on. Because the only truth about how you move from one subgraph to another is the lookups, always. That's the only truth, is how these graphs interact with each other doesn't necessarily have something to do, because if you can strip away, like it's a mathematical concept, right? If you can take out something from the other thing and this system still works, then this must be the truth, because there's no change in behavior when you change the keys. You can add more keys. I can also say name is a key and price is a key, and it doesn't affect the execution, because the lookup is the one which actually tells the truth about how the system interacts with each other. You know, I understand the thing about it's nice to have the keys here, but we also have to see that the keys in Federation have a completely different purpose. The keys in Apollo Federations are the lookups, right? Here it's different. Yeah, Derek?
So I would like to make an observation that the current discussion around this is actually heavily influenced by having the only single level lookups. And if you have a lookup that returns, it has to kind of returns an entity, so it's kind of a implied, right? And in that case, yes, a lot of those keys can be derived, even though I still think it makes much easier to think about those entities when you have the explicit keys, when I'm modeling stuff. That being said, if we ever wanted to add the nested lookups or the multi-level lookups, where then we have this no longer guarantee that a single field lookup is actually identifies an entity, but is a combination of those, right? That identified it. Then the keys are a must, kind of, to actually ideally identify those entities, because otherwise it gets very, very confusing. What is an entity and what can be jumped to another subgraph versus something that cannot.
So the thing there is that we have discussed this case in the last work group, and the key is not enough. Even explicitly specifying a key is not enough to resolve the identity of a nested lookup. As soon as you have twice like it's the thing that we had with the seller. Like you have the seller, but you have I don't know, you have two products resolver on it. It's the identity of just saying that this is part of the key doesn't work with nested lookups because it's in the wrong direction. You don't know, as soon as you have twice the identity on the same resolver, you don't know in which direction you have to look. So
You need the
Yeah.
path. You need
Well,
kind of the path.
you need to be explicit about the mapping. And I think there are different ways of doing that. I linked one in on one of the issues that combines is and require on a lookup field, but there are other ways of doing this that we discussed before. Let me post this in the chat.
talking about
Oh, you have it.
yeah, I know what you're talking about. It's somewhere in here, right?
Yeah, I don't think this is the one though. It's the other one.
You see, we have a chain.
I think it's the main issue. I think you commented on the main issue.
It's here.
Okay, let me check the chat.
Is that the same one or is that a different one? Yeah, that's a different one, I think. So here, so in the example above, I had one that was similar to what we discussed last week. It's sort of, for instance, you can have a lookup with a mapping. But then I thought, why not use the existing building blocks? I'm not sure if this makes things clearer, but you can imagine sort of combining is and require in this way to specify the behavior. Basically, what you would be saying is that every lookup needs to be able to stand on its own. So either it's a root level lookup, and that's sort of what we've been discussing in supporting for the first version. But for nested lookups, we likely want to make all the context explicit there. So basically, we're transforming a nested lookup into a standalone lookup by using, in this case, require.
There's one issue I have specifically with the re-exposing of this, because this technically is kind of, I mean, depending on who looks at it, but exposing language where it can go to text and back to language is sometimes considered also an anti-pattern in GraphQL, cyclic types.
Yeah, I mean, you could define the key as just language code, if you wanted to. On internationalized text, you could just have an ID and a language code there. That would make the mapping easier. You don't need the is mapping there then.
Yeah. Yeah, it goes into it's exactly the discussion that we need to have, right? Because again, if we annotate it like this, it would be enough to have the knowledge how you can get the internationalized texts uniquely identified, right? Like if the key again, it adds, if you just look at the internationalized text, then you know that this is now lookupable by this lookup because you have the language and the code. But depending on how you want to look at it, it's also like the information about what actually, how you get the data is encoded here. So if you just remove this, it would already be, again, enough to look it up.
Oh, yeah, but I think we agree on that. Like from a purely from an execution point of view, keys are superfluous. But I think from a developer experience point of view, they're essential. Plus, there are other uses for it. But we're keeping those out of the discussion for now. But I think the notion of certain types having a unique identity, a unique stable identity, is something that's missing from GraphQL and that we're trying to add here.
Yes, but that is also by choice, right? There is the relay specifications, which actually is GraphQL best practices, but they were not encoded in the core specification to keep it open to other concepts.
Yeah.
And I think the line that we walk here, right? Like, I'm not saying that, don't get me wrong, Martin. I'm not saying that the concept of a key is fundamentally wrong. I'm just, the only consideration I have is, should the composite, the core specification, care about this, even though that lookup is actually the only thing which which tells where to move traffic to, or should it be something which we build on top of it? And it could still be best practice to implement it, but from point of view where we may want to integrate something completely different, which doesn't have these capabilities. Sergey?
Yeah, sorry.
Does it make sense like to split like responsibility here, like for key to be the identifier, and for the lookups just explicitly mark that SKU on a product is a lookup field? That in case you define lookup, you define a lookup field, and then there will be match between lookup and a field on the type, and it will be served like a U identifier.
I mean,
what exactly is lookupable?
That is what the double bookkeeping section basically says, that you have to have them in tandem. But the thing is, I would also not throw out key on the spec if we agree that we don't need it as a core principle. We should have it as an appendix, and then describe how the semantics are, because otherwise, if it's nowhere in the spec text, nobody will implement it.
No, and I think it's important for interoperability that we do have a shared understanding of keys. I do feel that it helps us in describing the expected behavior, the failure modes, error messaging. I think we would be able to specify some validation rules, for instance, that are helpful here, that go beyond just like satisfiability.
Well, one thing is that it not only adds, it also adds restrictions. That's one thing that we also have to be aware, because there is no SKU field on the product. There is none, because
no, but you could if you don't want to expose SKU, but you still want a key, you can mark it as external.
Yeah, but that's a bit of yeah. I mean,
or you can use it, and then you can use it provides, for instance, like that was the example I gave in the earlier gist.
I have my fair share of problems with external, because it's not really there, but it's also there. So that's my. It's like Schrödinger's cat. Like, you only know if external is there if you call the resolver, and then you know it might be there, but it might also be not there. And if it's not there, it's dead.
Yeah, the problem with external is you create essentially a spec incompatible GraphQL server, which kind of we do to have certain feature capabilities in the overall distributed system, and that is then GraphQL compatible. Yeah. But it's also like if you take a standard GraphQL server, it would always error out on an external field if you don't pass it in. Sergey?
Yeah, one question in regards to this schema on the screen. Like schema A on the top, it has name and price. Like how this query is resolved? Do you mean that it is resolved like in a shareable way in a federation, that we just query two subgraphs at the same time?
So have a look. It's a bit of maybe this was not a good idea, because this is not a lookup. So let's just say this is it's not defined as a lookup, so it will not be lookupable. So let's just say that this field is
a top product.
So now how this is resolved is quite easy, right? You go to this subgraph, you get the ID, the SKU, the name, and the price. Then you have the SKU, and you can actually transition to this lookup and resolve the product details from this lookup. So it's resolvable. It's also, by the way, just for reference, this is perfectly fine in Polar Federation. We've discussed this last week, right? You can actually have a key, then this would be annotated with key SKU, but it's this schema is completely executable in
Apollo.
So basically, in case in subgraph B we remove internal on the query on the lookup, if we remove internal, then it will be not composable, right?
Yes.
Why not?
It would be.
1 second. Why would it be? Yeah.
Because you don't
You're
have
right.
you
Oh,
cannot-
yeah, because you can jump from that one to the, yeah, that's right.
You will not be able to fetch like name and price
Yeah.
from some.
Exactly.
You're correct.
And it's not that this is it's good. Don't get me wrong. It's not that this is good practice or this is like real world thing. It's just that theoretically, this is the absolute minimum that we need. It's fine to just define this and it would be executable. In practice, you probably would make this a lookup as well, and you may have even
Yeah.
a SKU and whatever. But it's just that if we restrict it down too much, then we essentially lock us into a specific pattern that we always have to satisfy.
Yeah, that's actually an interesting example here because if we remove internal and it's unsatisfiable, can we generate an actionable error message from that? It's
We
much
could.
easier to,
We could.
but how actionable is it? It's
Like-
much easier to tell people that, oh, you seem to have forgotten to define this Q key on product.
Yeah, but that's not.
So we are doing that with so in Fusion, if you remember, we had these inferred lookups where we basically look at the field structure and see, okay, this is probably a lookup, and you could use such a technique also just not to infer the lookup, but to say you probably you're missing here a transition point. This could be a transition point, and like you could infer them, and but it's implementation detail, I would say. But you could issue like if the field structure is well informed, you could have very actionable error messages.
It's doable
Especially if you
because
have
it's-
like because in GraphQL you often also have patterns like where you have product by ID because you maybe have product by SKU, and then you can even be very explicit on this.
So you kind of just have to do a little bit more, I guess. Saying but I guess it's doable. It's just from the developer perspective, it might be more ambiguous, I guess. versus
Well,
saying-
Yeah, so I mean, I think it's much more complex to tell people about like missing transition points and give them like several options that could satisfy this. And actually, what I envision here is something that runs even before satisfiability, that just tells you, looks like you meant to return an entity here. You haven't defined a key.
Yeah, so from an actionable point of view, I think if satisfiability, I know it's late, but if satisfiability kicks in here because you want to actually make this non-internal, you want to move from this subgraph to this subgraph, then the satisfiability error is actually quite clear, isn't it? Because
But it's not satisfiability even, right? It's already a validation.
No, it would be satisfiability because you only know it there. You only know there that this would not be possible. Because
Okay.
in satisfiability,
Yeah.
you go into here, let's say we have the SKU lookup here, you go into it and then you say that from here, like you can say that name from subgraph B to subgraph A, you cannot resolve name and price because there is no lookup for any of these fields. And then there is a single point where you can point the user to. It's like you have to add to the query type of schema B a lookup which is compatible with these fields. And if it's not possible, then it's not possible. But there's actually you can even add the resolver definition. Like you need one of these resolvers, and it could be the resolver, like it could be the resolver by SKU, by name and price in the other direction.
Yes, because you could, in this case, you could look at all definitions that you have, all entry points that you have that are not annotated lookup, and look at the arguments, infer from that. These probably are possible transition points because we have fields that look like they could be passed into this field. And then you can say this could be possible transition points. They might not be because you don't know the semantics because there's no lookup attribute on it, lookup directive on it. But like from a hinting standpoint, you could implement such errors.
So if let's the case, we remove this internal, and now we have a satisfiability issue. But the satisfiability issue actually can point to like something like there is language is different thing. There is no way to move from schema B to schema A. Schema A needs to define a lookup one of the following. And that could be, you either have to have a product by some field, or you have to have a product by other.
I think this is already confusing because those fields are likely not key fields.
But that's the options that you have, right?
Well, I mean, that's exactly what I mean. Sort of if you look purely from a satisfiability point of view, those are all options, but they're likely not to be good options. What you actually want to tell people is product is meant to be an entity, and you should have a shared key between these subgraphs. Like that's the language that I think you want to steer people towards.
Yeah. And I would also like only steer people in such kind like, but this is again this implementation detail, right? But if I would steer, I would try to find fields that are fine on the other side, like in lookup fields on the other side, possible lookup fields. And if you can match them, then you could suggest them. In this case, you couldn't even match them. So there's no key that could be possible. But if product, for instance, would have ID on schema B, then you could suggest that product could be a candidate as a lookup.
So this is a satisfiability error which we currently have, which is currently a federation in the federation implementation, right?
Yeah. But this is already assuming that you have a key, which you don't have on schema B.
Yeah, I mean that's just that about the how do you say the information that you get from federation with keys to the information that we can compute without keys. It's a bit just as a comparison.
Oh yeah, yeah.
It's not bad in any way. I'm just saying that this is what federation puts out now. Thanks, Camille, for sending it over. And this is what we could compute or something similar. This could be different, but we have the ability to pretty much point to like you have to add something to this type to make this look upable. And it's not that I wouldn't even say necessarily you don't need a key on it, but you just need something which makes this uniquely identifiable.
But that's what a key means. And I think it's confusing to point to like arbitrary other fields, for instance, because you're like if someone were to naively add a product by some field to subgraph B and some field is not actually a unique identifier, you're in worse shape. Or it's not meant to be treated. Maybe in the current data set, it's unique, but it's not meant to be unique. Like a key is stronger than just being able to look something up by an attribute right now.
Yeah. I'm a bit torn there because I understand that let's say the fact of having a key is super nice. I agree with the idea of having a way to express that this is a key where we can, which is uniquely identifiable. This idea is good. The thing is just if we require it to be there, then I think that the smallest possible thing that we could execute should probably be the one that is specified. If we want to add something on top and introduce best practices around it, that's completely fine. But what if we just expand the usage of this a bit? Like this at the moment is a graphical resolver, but theoretically, this is just the only thing that this is you get SKU, and what you get out is some field, other field, and product details. That's essentially functionally, that's the function, the lambda that's behind it. You pass in an SKU, and what you get out is this. And this is a graphical resolver in this case, but it could be anything. And
I'm
I think
not sure I follow here.
like from an execution perspective, the only thing what this lookup does is it's a way that you can pass in an SKU and you can get back all of these fields.
Well, if that's your selection set, and you could, of course, go further into this graph with product as a starting point.
I'm talking very abstract now.
Yeah, but I don't see how that's unique to this field. Isn't that true of every GraphQL field?
It is, but it's a special one because it's a lookup. So you just say that there's a way to get a product by SKU, and you can when you have the SKU, you can resolve these fields. That's
what Pascal means it is stable. Like a product that you have up there, which gets an ID, which we assume is stable, doesn't mean it's really stable, right? But
no, and I think I don't think
on it.
I don't think this function is stable, for instance, because some field might change at any point. If you were to get back a key from here, if product had another key, for instance, you would expect that mapping to be stable.
No, I'm not. I'm only saying that I'm not making any statement about stability. I'm just saying that if you have an SKU, you can resolve these fields.
Yeah, but I don't see how that's specific to this lookup field or to a lookup field. I mean that's just how any GraphQL field functions, right?
Yeah, but this is a kind of a distributed field, isn't it? Because you can call this also from here. Because you know, I'm from the gateway, but the gateway knows that if it has the SKU, it can resolve the fields. By doing lookup, by adding lookup to a graphical field, what you essentially say is that this is a global way to get the data based on the arguments of this.
Yeah, but then you're saying something about stability, Pascal. Because that essentially, or that's a current phrasing that we have, is that a lookup is a way to get an entity by a stable key or the data of an entity by a stable key.
Yeah, I mean that's the similar.
And for everything else, all other GraphQL fields do the same. They are functions to get some data. But the lookup is a special field.
It's kind of a data loader, right? The data loader has the same thing, but you know how people use data loader. Data loaders are not.
Yeah, but there's also, you have a by key function, and that is basically what it does.
Yeah, that's
not just an abstract field, but it's important that that you have an identifier that you pass in,
exactly,
and you get a stable result out.
Yeah, but to be clear, the stable result is not all data in the object. What's stable is the identity of the object.
Yeah.
That's the only thing that's stable.
Yeah, but that's what I mean. Like the stability that the lookup provides is that we have like the attributes of like the important thing about an entity is that it has a stable identity I can refer to. The data of all other attributes might change.
Yeah.
So the point I'm trying to make here is if I write a data loader, the specification of data loader is that for a given request scope, for this key, I get these values back, but that's only one request scope, right? So I pass in an ID and I get back some values, and these values will be cached for consecutive calls to the same data loader. And from an execution point of view, the only thing that you need to know is that if you have resolved the product with SKU1 once, it's going to be the same in the whole request. So the stable input just means that the result is actually also stable for one request. You're never going to refetch it, right?
But I still don't see how that's specific to this. And I don't. I mean, it's only true if you don't refetch it. I mean, if you were to call that
Multiple times, then
field
you
multiple times, the
you
like
get different values.
some field might have changed its value.
Yeah, that's true. That's true. That's true.
So what I do think is true is, but that's I think is actually an interesting question to consider is if a type defines multiple keys, what a lookup should guarantee is not just that the identity is stable for that specific key, but that the mapping to the other key is also stable. So for instance, if we were to look up a product by SKU and we get back a UPC, among other things, and that's marked as a key, that mapping between SKU and UPC should also be stable.
If it's an identity,
Yeah.
yes.
You mean when you return here the ID, then you know for this SKU you will always get the same ID. If both are keys.
Yeah. But I think that's only true if ID is actually marked as a key.
Yeah.
So that's what I'm trying to get at. Like I tried to mention that last week as well. I think there's something to key fields that's more specific than just them being shareable. Like they're meant to be stable.
Yeah, they are kind of immutable, right?
Yeah, but I'm not sure sort of whether they're truly immutable, like whether they never change, but they definitely shouldn't change sort of underneath you. They shouldn't change like during the execution of a query, or maybe even like while you have an active cache.
Yeah, but that's in general, keys rarely change. It's like an edge case, would even say.
Yeah, exactly. Which makes them different from any other shareable key, because the only thing we're guaranteeing is like if you ask for this field in any of the subgraphs that that provides it, you should get back the same value approximately, but there might be
By doing this,
it is kind of a shareable with semantics.
Don't we?
That's like I had a discussion last week with Pascal, and that was my.
But the question is like, from a purely executionable point of view, like, don't we limit the capabilities of the composite schema specification by enforcing this behavior? Like, if you look at abstract it's just that if you have an SKU, you can resolve these fields. That's a very abstract view of it. By introducing keys, we just assume that this is kind of like stable. But the only thing that lookup does from a very abstract view is that if you have a certain SKU, you can get these fields. It's from a very abstract view. Like if we want to add semantics on top, that's fine. But the abstract case is still like, this is just a resolver that can be called from the gateway, and it knows that it can get federated data together with this identifier, right?
Yeah, I think what key mostly offers are sort of guardrails and a mental model for people. It might also offer opportunities for sort of optimized implementation. I'm not sure about that. I'm not sure whether we would want to take advantage of that.
I mean, you could. If you have cascading keys, you know that you don't have to make a round trip. If you know that SKU is stable, and you know that some field is stable, as soon as you have SKU and some field, you know that you have a stable identifier. You don't need to make another round trip to get the same data again. I understand that the key can change execution behavior because you can rely on that the relationship between keys is also stable. If one key is stable, the relationship between the keys is also stable. But it's assumptions. I mean, it's definitely can improve execution performance, but it's also assumptions in how this can be used, because maybe this is not stable. It's just that you can.
But if it's not stable, it's not a lookup.
Yeah. So we like
to be the devil's advocate, technically, if you mark those as a lookup somewhere else, and you can derive those keys, you could derive that those are actually stable keys, whether you annotate them or not. I still think that having them explicitly in the graph leads to a better developer experience. It's easier to reason about it, but for the sake of argument, if you can derive one key using a lookup, and you have another part of the supergraph, that another subgraph that has that, the source schema that has that lookup there that says this is the key, this is my lookup there, this is my key. You could have those arguments that those are implicit in doing that, but I like the explicitness of keys to make it simpler.
Yeah, it's also from like I'm also a bit torn, because like a key directive essentially, like when you when you think about the shareable directives that you have to add, and it's a single key directive, like for a composite key. Sometimes looks better.
Yeah, I'm thinking mostly about the way you educate people about federation and the way you want them to sort of lead them to a successful federated schema. Think in
Yeah,
terms
but
of schema design. And I don't think that works if keys are an optional part. That's what I'm saying. I think they need to be an integral part of the model.
That could still be the case. That could still be the case. It could still be that for a federated architecture, you need stable keys, and you define stable keys, and you have to do this. Like, this could still be the case. It's not that we would rule out that this is not possible. It's more about the flexibility of the very core of the specification. Like, by introducing keys, we limit what we have some limitations in flexibility. We can still educate that you have to have keys for a stable federated schema, and this is the best practice to do, and this is how you should do it. It's more about the question, is it required to be part of it? And
Yeah,
part of a composite schema, that's the question.
I don't think it needs to be part of the underlying model. Like, I think we can specify the behavior without them. But I do think they should be an integral part of the spec. I don't think they should be like an optional part or an appendix. Both for education purposes, but also to take advantage of opportunities where we can actually improve the developer experience based on those keys with additional validation rules, better error messaging, etc.
David?
So just a quick one that I think, because the target, well, I'm going to assume the initial target audience for composite schemas are current Federation users, and you can facilitate moving from Apollo Federation to using the composite way with familiar concepts, and obviously keys are very ingrained and familiar to people already using Federation. So there's that aspect of it, that if you kind of try to make it as appealing and as familiar as possible, you facilitate and also enable a lot more people than you otherwise would have done.
Yeah, that's where I
It's
disagree, because
it's
there's many different ways how you can use federated schemas at the moment. It's just that the way Apollo Federation does it is the most popular way, but there's different ones. We still know people which use schema stitching. We still have people which use or we have people which currently use Fusion, which is also an iteration on how federated schemas can work. And there is Nadal and Nadal, and there's multiple different things which doesn't rule out that these people also think that the composite schema is a good thing. So it's not only Federation users that could Apollo Federation users that could benefit of this specification. It's everyone.
So I didn't mean to kind of sound like I'm taking merit away from any other solutions, just more like there's one method of integrating APIs together, which is quite large, and in this instance is federation. And at least from my perspective, the composite schema takes lots of ideas from lots of different methods, but for me, it most resembles federation, but that's just my personal opinion.
There is, it's not about the solutions, I would say. It's about that you give, like, if we look at a lot of the schema government stuff around a lot of solutions, that is not so, like, if you look from an open source standpoint, right, where an open source contributor implements a new gateway, whatever, then the whole enterprisey stuff is not so interesting. And I think we should also cater for these people, that you have like the basic entry point. That's also why we don't consider authorization or anything in there, because that is where you can basically bring your own solution in. So it's about the pattern, like that is a federation pattern, if you want to craft it widely. But I wouldn't want to prescribe everything that Apollo or Wundergraph or whoever does in their solutions must be implemented by these people. So we should be very clear what is core and what is up to implementation detail. That's I think also the main discussion point here that we have on this. Sergey?
Yeah, just like a quick question in this manner. Like, but do you consider adoption? Like, federation currently is the most adopted, and what Wundergraph Guild is doing, we just like implemented federation, and this is just federation. People are aware of that, and like I see the value of the composite schemas. It's like the main purpose, if I understand it correctly, right? That basically you with composite schemas, you even don't need a subgraphs libraries. You could just place the directives, and anything other will be done by the executor, and this is cool. But it needs adoption, and target adoption probably will be the people which are using federation currently. So I just believe this transition should be like a gradual or like adoptable somehow. Like
I mean, that is one of the things that we look at, right? We don't want to build something that would kind of be
breaking
a stopper for. I mean, that's also Apollo's here, right? It would be kind of bad if they couldn't move to this specification. Like if it's not implementable for federation gateway, then we have done something wrong.
It's just about which level of feature details we need as a core. That's the main discussion here.
And at which level? I think Pascal in the document captured the options that we have. It's the options, right? Quite good. Like we could choose to go very bare bone. That is this. We could choose to have the key there, but kind of follow what Apollo Federation does today, where we have this little gray zone where you can have a key on one side and then still shareable there. That's option 2. We could be more stricter and say, if you implement that, you have to have the keys on both sides. And I think the 4th option was just exploratory. I wouldn't go there, but these are the 3 options we have to consider, and where we have to make a decision, and then we just edit the current spec text a bit, and then we are good to go. So it's not reinventing things. It's just that we need to find a good compromise on this thing.
It's also not that keys are bad. That's also not what we're trying to say here. It's just like as the course, the first bare bone minimal approach would be we do not require them for an executable schema. Doesn't mean that the idea of a key is bad, or the double bookkeeping, or the double bookkeeping. Is that okay?
Yeah, just on top of what I said previously, basically what I see as a possible situation that in case this specification is compatible enough with Federation, like it has new concepts, but it will be possible to gradually migrate to it, and for the Apollo, for the Wundergraph, just to implement this on top of Federation and have a mixed subgraphs. One of them, like which will be like still a subgraphs with entities resolver, and part of the subgraphs will be just with lookups resolvers. But in order to make it compatible, you need to have some trade-offs, like and probably you need keys just to be able to work with the existing subgraphs and the new kind of subgraphs in some compatible way.
That's exactly the if you require keys, then it's not compatible. If we need to have a lookup for all of the keys, it's not compatible.
Why is it not compatible, Pascal?
Because
okay, so as if you mean if we go for three.
If you take a current Federation subgraph and you want to use a current Federation subgraph in the composite schema, and we would enforce that a key has to have a lookup, then it wouldn't be compatible. Whereas if keys is a different concept, then it's compatible. Like all Federation subgraphs are immediately compatible with the composite schema specification. Without any, they are compatible. Because the thing is that the entities field is a lookup. And if we would introduce validation rules where we say that all the keys have to define a lookup, then it's not compatible because the lookup wouldn't.
Well, unless we specify that underscore entities is an implicit lookup for those compatibility subgraphs.
Yeah, true. But it's 100% compatible from day one, I would say, at least with the implementation that we have now, because it's just entities is a lookup. It's just a bulk lookup, which is what what the composite schema does differently. It's more graph-colorant, it's more explicit. But from a compatibility standpoint, you can also say that you have, I mean, the entities resolver is just one big resolver that can do everything, right?
Yeah, and I think like from a migration standpoint, you probably want to migrate subgraph by subgraph.
Yeah, but I do actually think that keys help migration there. Like if you have a shared understanding of because they are required for the current Apollo Federation subgraphs, and then you can just use those same keys for the other subgraph or the upgraded.
It's probably the solution too.
Yeah, it can even help you generate the lookup in a migration tool. You can generate the lookup from the key directive.
That's an excellent point. If you took a schema first design and you want to, there's currently without keys, there's no way to instruct what kind of lookups you'd be looking to create, right? You basically have to design your lookups yourself. There's no way to generate them because if there were no keys, I mean. Whereas if you had a key,
why can't you generate them?
I mean, using a schema first approach, how would you generate those lookups without
you could if you wanted to. Like you mean for when you migrate, right?
I mean, for example, sure.
Yeah, for all resolvable keys, you can analyze where these lookups should be, and then you generate the fields, and then your thing, I don't know, depends on your solution, wouldn't compile. Like in our implementation, if you give a schema where you have no resolver bindings to, it wouldn't compile. You get a compile error, and then you implement all the now explicit lookups.
Yeah. So we are.
I'm like technically, I don't think there is technically to everything of that a problem. What we have to decide is not purely technical here. It's we have to go with one of these three designs. And I think 3 with being overly strict is not a good choice. We can I would be more in 2 or 1. And say if we go with 2 and we decide to move forward with keys, then we could have a warning when you have this shareable case, this edge case. I wouldn't go with super strict because I think we need the flexibility.
The strongest argument for me for keys, one last point, is that if you do have the explicit keys, then it tells the developer who's working on a graph where, let's say, there are no lookups defined, there are no keys defined. So it's basically the query is coming to that subgraph first and then sending it out to the other lookups in other graphs. If that developer were to remove the ID field on product, for example, which is resolved in another graph as its lookup, there's no connection there until they try to push those changes and realize that satisfiability is broken because that was actually being used as a key. That's the biggest thing for me, is that there's nothing to tell the developer that is doing more than just being a simple field on a simple object that is doing more than it seems behind the scenes.
Yeah, but that's inherently the problem that you have in the federated architecture. It's what we had with the required, with the shareable, with all of these things, right? There is always, you cannot just, every change to every type could affect the global graph.
Sure, but a key directive tells you something about the status of that field.
Yeah, true. But I can also remove name and then the display name resolver on a different subgraph breaks because it has a requirement on name. So
sure, yeah.
That's also something which I only find out after I pushed and I'm on at run through satisfiability, right? I mean, it could be a validation thing, but it's the same at the end, the same point. Yeah, it's something to think about. We're 17 minutes already over time, and I think we can let this settle for a bit. But at some point, the next 1 or 2 weeks, we have to make a decision in which direction we go. I think we're not. We need to decide.
We can maybe do. We can maybe I post a vote tomorrow, not by just to get where everybody is. Like I think the 3 solutions that you pointed out, Pascal, are actually good discussion points that we had. And between these, we should just decide. And maybe
add a 2.5 where
2.5,
there's a warning
yes,
for the
yes,
third
yes,
case,
yes.
but not a strict mode. It's
yeah,
not
I would
breaking.
say
but...
if I would say if we take 2, we just say we do 2 always with a warning. And then you can, with the idea that we had, you could say, I don't care about this warning, I'm good. Or you could say, I want this to be an error.
That's actually a good point of view. Like, if we generate a warning in the second case where you don't have matching keys on both sides, you can just promote the warning to a warning the warning to an error, and then you end up.
Then you have strict mode.
Then you have the strict mode because we have this in the specification. So it's really what we need to decide is between, let's call it this way. What we have to decide is to key or not to key. That's the thing.
Yeah, I think that is. I think 2 with that modification is actually the way to go. But let's put tomorrow, just so everybody also that was not in the meeting had the chance to chime in on that in the Slack channel. Let's put that out again, and then we can just quickly vote with icons what we prefer to, and then we have and can chime in the discussion, and then we close this case, I would say, if there is not too much dissent in there.
That's good.
Okay.
Awesome.
Very good discussions.
Yeah.
Yeah. Awesome.
Thanks everyone.
Goodbye.
See you. Bye bye.